In today's class, we are going to be looking at how to administer intersite connectivity. So when we talk about intersite connectivity, we are looking at how to extend our on-premises network to Azure, how to connect two virtual networks together. So here we are going to be talking about the VPN connectivity. We'll look at the point to site, the site to site, the ExpressRoute, and also we look at the VNet peering. So majorly, this is what this module is all about. So like I've said, we're going to look at VNet peering under the learning objective, the network routing and endpoints, and how do we implement intersite connectivity, which will be the lab for this particular learning part. So let's start with how to configure VNet peering. Yesterday I explained that when you have a network, what this network gives you is, the ability to allow your devices to communicate with each other. Now, when your devices are actually within the same network, they are able to talk to each other. So in Azure, this is the same connection that we have in our virtual network, which is the VNet. So when resources are actually deployed within the same VNet, those resources are able to communicate with each other. So VNet, let's say we created a VNet A and we created another VNet B. In the VNet A, we have a database, we have a virtual machine, we have maybe application gateway, whatever that we have in there. All these resources that I've mentioned within that VNet A are able to talk to each other. If we have the same set of resources in VNet B, those resources also are able to communicate with each other within that particular VNet B. So the question now is, if we deploy a resource in VNet A, would this resource be able to talk to, another resource that has been deployed in VNet B? Let's say we deployed a virtual machine in VNet A, and we have another virtual machine in VNet B. Are these virtual machines able to talk to each other? Are they able to communicate? The answer will be no, because they have been deployed into different virtual network, into a different network. For us to be able to, to allow this virtual machine to communicate, the virtual machine deployed in VNet A and also the one deployed in VNet B, before they can actually communicate, we need to do what we call a VNet peering. That means when we do a VNet peering, when we pair those VNet together, so what the VNet peering means is we are connecting those two virtual networks together. So when you do a VNet peering, all the resources in VNet A and VNet B will now be able to communicate to each other. In some way, the result is all those resources are now in one particular VNet. They are going to be treated as if they are now within the same network. So that is what VNet peering does. So, and there are some things we need to look at when we talk about VNet peering. We're going to be looking at, maybe some other appliances that we use in doing these, or let's say we are trying to extend, if we do a connection between VNet A and VNet B, and we want to extend that VNet A to the on-premises. Let's say there is a connection between the VNet A and our on-premises environment or on-premises network, and we still have a connection between VNet A and VNet B. The question will be, will the resources on the on-premises environment be able to talk to resources in VNet B, since there is no direct connection? However, there is a connection between VNet A and VNet B, which will allow, those resources in VNet B to be able to communicate through VNet A to those on-premises, devices. So here we're going to be looking at some gateway appliances that allows this connection between the on-premises environment and the virtual network in Azure. So there we're going to be talking about what we call the gateway transit, and the connectivity need. Then we'll go ahead to create this VNet peering. We'll see how to create it, looking at maybe some of the information that need to be supplied. How do we create this connection? What are the basic, information that needs to be given out? What are the advanced ones? So just the same way we create some other resources, but a little bit different because we are not creating a resource here. We are only doing the peering. Then we'll look at what we call, service chaining. Then, so for service chaining, we're going to be talking about, how do we route traffic, from our virtual network to maybe the on-premises environment, or from our virtual network maybe to internet or something. So it's just like routing. Then we'll see the demonstration on how to, connect or implement this VNet peering. So let's take a look at. So let's start with the VNet peering uses. So like I've said, for virtual network peering is the connection of two virtual network, to each other. That's to connect. That's what we call the virtual peering, VNet peering. So there are two types of, VNet peering. We have what we call the global peering, and we have what we call the regional peering. So for the global peering, we are talking about two VNets within, two VNets in different region. That's what we know as the global peering. And when we have the regional peering, this is, the connection of two virtual networks within the same region. And that's what you can see here. So when you are connected, so I can deploy maybe a VNet in South Africa region, and I have another one deployed maybe in East US. I can connect to these two VNet together, and the resources in this VNet will be able to access the resource in this VNet. So let me ask you a question, if you guys are attentive. If I do a connection between this VNet 2 and VNet 3, you guys, from what I've explained, those resources within VNet 2 and VNet 3 will be able to talk to each other. Now, there is a connection between VNet 1 and VNet 2, which means the resources in VNet 1 and VNet 2 are going to be able to talk to each other. So my question will be, will the resources in VNet 1 be able to talk to resources in VNet 3?
No.
So why is it no?
Yes,
Why is it yes?
it's because they're having the same resources because region one has its own resources and
Forget
region
about region 1 now. We are talking about the VNet, just the VNet.
two, yeah,
There's a
they should be
direct
able to
pairing
see
between
normal.
V.
Yeah.
Because there's no direct peering.
There's no direct pairing between V1 and V3. There's direct from V1 to V2 and V2 to V3. But I'm not sure V1 to V3 can actually communicate.
Now, so for VNet, for VNet peering, resources, two VNets can be connected together from, the explanation. So here we have VNet 2 and VNet 3 connected together. Now we have VNet 1 and VNet 2 connected together. Now, like I said, the resource here will be able to communicate with the resources here. The same way the resources here will be able to communicate with the resources here. However, the resources deployed in VNet 3 will not be able to interact with the resources in VNet 1 because there is no VNet peering between the VNet 1 and VNet 3. So for us to allow, resources to be able to communicate with each other, there must be a direct connection between their virtual network. However, this doesn't extend to the on-premises. Let's move away from Azure. Let's say this VNet 1 is our on-premises environment. Then we have what we call the hub and spoke network. The hub and spoke network in the sense that there is actually a network which will be deployed, like it will be the one in front of other networks. That's where we'll deploy, our gateway devices. And that network is the one that have direct connection with our on-premises environment. Just one network. So most times, best practices, we don't deploy resources within that network. The only resource we deploy there is just our gateway appliance that makes that connection with our on-premises environment in the case of site to site. Do you understand? Now, this VNet, which is the one that have the direct connection with our on-premises environment, will now be paired with other virtual networks. In that case, any resource in our on-premise environment will be able to communicate with other resources which are actually in the other virtual network, because there is a connection between. So these guys serve as a middleman between the on-premises environment and the other environments, the other virtual network. However, we must actually do a VNet pairing between this VNet and the other VNet. So we can have VNet 2 to VNet 3, VNet 2 to VNet 4, VNet 2 to VNet 5, VNet 2 to VNet 6. Do you understand? However, if it is strictly virtual network, before resources can talk to each other, there must be a direct VNet pairing between those VNet where they are deployed. So that means we must have VNet 1, VNet 2 connection, VNet 1, VNet 3 connection before the resources can actually communicate. And something you guys need to note, like I've actually explained the last time, you must make sure that there is no address overlapping. So if you have VNet 1, the same IP address that we have deployed in VNet 1 is the one deployed in VNet 3. We will not be able to make that connection. The same way, if you have the same IP address that you have in VNet 2, if you have it on your on-premises environment, you will not be able to make that connection because there is an overlapping address. So you must make sure that when you are planning your IP addressing, you must make sure that there is no overlapping IP address space within your organization. Even if you have not considered pairing your VNet, if you have not considered extending your network to your on-premises environment. And that's why when you join some organizations, you will notice that there are a lot of things to do. There are a lot of reconfiguration that need to be done because they never planned. They were just deploying based on default settings, provided to them by Azure. So they were not planning their IP address, they were not planning their network. And this is one big issue, if you start, if there is a need for you to start, architecting all these environments, So here you can see two types of peering, like I've actually said, you can do region to region, like one VNet that stays in one region. You can connect it with a VNet in another region, which is called the global peering. And we can have, two VNet within the same region connected together, which we call the regional peering. And this is what you can see. Connect to Azure virtual machine, to Azure virtual network. It can be across multiple subscriptions. So you can have it deployed in a different subscription and you still connect to it. Or it might be within maybe different tenants or the same tenants. It doesn't have to be within your organization. So you can have a connection between one organization and another organization. And that's what This means that across tenants and across subscription. So there is easy setup. You guys are going to see how this is actually set up in Azure. Then moving away from that, this is just talking about, how do we connect or how do we extend our VNet? You can see how do we do, the hub and spoke architecture that I talked about. I was saying if there is a need for you to extend your virtual network in Azure to your on-premises environment, you need to create what we call an hub and spoke um, configuration or architecture. That means there is actually one VNet that makes this connection to the on-premises environment, and other VNets now connect to this VNet. So the VNet serves as maybe a central VNet, which makes that connection with so we don't have to connect all our VNets to the on-premises environment. We only have to connect just one. So we have what we call a hub network. So here we have a hub network, which is the one that connects to the on-premises environment. Then we can now make connections to the other environment using what we call the VNet peering. So as you can see, this is a VNet and another VNet here. These VNets are called the spoke networks, the spoke network. And we have a hub network. And inside that hub network, you can see we have VPN Gateway. And the VPN Gateway is what makes connection to the on-premises environment. So because we have a pairing between this guy and this guy, a pairing between this guy and this guy. So machines within, virtual machine within this VNet A will be able to talk to virtual machines here, and they'll still be able to talk to machine on our on-premises environment. The same way for the VNet B. However, there is no connection, between, regardless of the fact that we have this connection from here to the on-premises environment, there's no connection between this VNet A and VNet B. Resources in here won't still be able to talk to this one there. So, and if you see something here, we have VNet A, the address space is 10.1. For VNet B, the address space is 10.2, and VNet 3, the address space is 10.3. And that's why we can have all these connections, created successfully. So for gateway transit, what this does is it allows peer network to share just one common gateway. And this is it. So as you can see, there is a connection here and another connection here to say these allow gateway transit. This we use gateway transit. This will also use gateway transit. So once we allow it from the hub network, then all these guys can use. That's why the on-premises environment or the on-premises devices can talk to the device here and can still talk to the device here because of this gateway transit. Do you guys get it? But when you are doing or when you are connecting to virtual network together in Azure, you do not need a VPN gateway, because VPN gateway is only required when there is a need for us to connect a virtual network in Azure to our on-premises environment. Biola, go ahead, please.
Okay, sorry, this might sound like maybe a silly question, but
No,
I
go
was
ahead,
just
please.
curious. From the first the previous slide, can we ever get VNet 1 to communicate with VNet 3?
Yes,
If
we can
yes,
do.
how?
We can do direct VNet peering between them.
Okay, but I thought the whole pairing thing is about 300 miles. Am I wrong?
No,
The
not
not.
not in this case. So
Oh, I
like I
see.
said, we have global peering, so we can connect regardless of where the. So for 300 miles that you're talking about, this is just what we call the region peer. So the region peer 300, is when we have two regions 300 miles away from each other, then we call it a region peer. You understand? So it doesn't mean that this region that is here have to be the one closer to this other region. So we are not talking about region peer here. This region might be a South Africa region, and this guy is in US, which is more than 300 miles. So within, let's say we have East US and West US. So we say we have what we call a region peer, because when you deploy, in region peer, when you deploy your resources in here, your resources are being replicated to the closest region. And that's what we call the region peer. You understand? But in this case, you can just connect regardless of where your VNet is, regardless of the region where you've deployed. So let's take, for instance, there is a global organization. And this global organization, they have an office in Lagos, and there is another office in California in the US. So if they want their resources to be able to communicate, they can do, the global VNet peering. So it doesn't matter. It doesn't have to be the closest region. You can connect any region, and that's why we call it a global VNet peering. Does that make sense?
Sure. Thank you.
All right. Any other question before I go ahead to show you guys, what are some of the things we need to check when we are creating a VNet peering? All right, then. Okay, so when you're creating a VNet peering, just like at least we've said, when you pair two VNet together, that's what we call VNet peering. So regardless of how I've been explaining these things, that's just it. Just to connect two VNet together, and that's what we call VNet peering. And here, as you can see, you are going to give it a name when you want to create what we call the VNet peering. Now, what are some of the things you need to check? The first thing is, do you want to allow access, allow VNet 1 to access the paired network? So we are trying to connect VNet 1 and VNet 2, and we want to allow the first VNet to be able to access the other VNet. Then we need to check it. Do we want to allow VNet 1 to receive forwarded traffic, from the other virtual network? Yes, which does make sense. Do we want to, if there is any traffic forwarded from the other one, do we want to allow it? Do we want to allow gateway in VNet to forward? This, you only need to check this if we are doing a connection to the on-premises environment. But if you are doing a VNet peering, there is no need for any gateway to be checked. So we only use VPN Gateway when there is a need for us to do a connection or to initiate a connection with our on-premises environment. So, and the same way you've actually selected whatever you need to select here is what you need to, you need to give it a name here and select, the VNet that you want to pair this particular VNet 1 to. So, yeah, so that's it. I'm sure at the end of this part, we'll see the demonstration. Now, the next thing is the service chaining. Like I've said, what is service chaining? It's just for you to be able to direct traffic, from one virtual network to a virtual appliance. It might be an application gateway, it might be a network gateway, it might be some other appliances, within other virtual network. So, but this is it. When you want to do the service chaining, we call, you are going to leverage on the user-defined route. So when you say user-defined route, that means we do not want the system to determine which appliance will be the next. So we are doing a forwarding. That means we are trying to say when the traffic hits this virtual network, where should we send the traffic to? And that's what they are saying here. So when we say direct, we are saying yes, when this virtual network, when the traffic comes into this virtual network, what would be the next place to send this traffic to? And that's what they're explaining here. So here, the user determines which path the traffic needs to go to, which appliance needs to be the one to take the traffic after we have received the traffic within our virtual network. And that's what the service chaining, is all about. So when there is a need for us to connect our on-premises environment with our virtual network in Azure, then we want to direct the traffic from our virtual network to the network gateway, because at that time we are directing we are making that decision that this is the next place to go. Then from there, because we want to make a connection to the on-premises environment, you can also create a connection from your virtual network or from your appliances to maybe to the internet, or from your virtual network to the internet. So you are the one determining where the traffic should go after hitting your virtual network. So that's what the virtual, the service chaining is just talking about. Then let's look at how to actually configure, VNet peering in our environment. All right, so I'm logged into my environment already. I'm going to look for two. Okay, let me just create. Okay, I'm going to look for two. So let me do this. I'm going to create. I'm not sure. I feel majority of my virtual networks there are kind of overlapping. So I'm going to create another network that is different from what I have so that I can connect them seamlessly. So I'm going to do VNet peering test. So you can see this is in West Europe. I can decide to change it to, UK South or something like this, Then I want to determine, So you can see if I continue this way, this guy is going to create like almost the same IP address that I already have. So if you're taking advantage of the default, that's not a very good, or let's say that's not the best practice. So you can create your own. So this guy is telling me already that there are some other network in your tenant that have overlapping IP address space with this virtual network that you are creating. So in case there is a need for you to do VNet peering, or you want to extend this VNet maybe to the on-premises environment, you might have difficulty doing that. So I'm just going to change this. I'm going to change this to, okay, let's do the dot. I'm going to change this to .5, or let's say, yeah, I'm going to change this to .5. And here, I need to create another subnet because that subnet is not within that particular. So this is going to be, yes, which is our first one. Now you can see I can create another subnet, which is going to start from, so we have 10.1, 10.1, yes. This is good. And I can create another one, and that should be 10.2, 10.5.2, which is fine. Now this is how we create subnets, since we have 65,536 address spaces. Yeah, I can decide to, I'm using 256 address spaces, so I can just decide to, start adding subnet until I get to this 65,536. I'm just going to review this and create this particular VNet. Also hold on. So you can see this is done. Our resource has been deployed. So I'm going to go to the resource, which is the VNet peering test. So if I go to the address space, you can see the ones I've created. If I go to the subnets, you will see all the subnets, I've configured. So it doesn't have to be default. You can give it a real name. You can even create your, subnet from here. And the next subnet is going to be 10.5.3, which is what you can see here already. So I can decide. So if, I explained that if you want to connect your on-premises environment with your VNet in Azure, then there is a topology that we use, which is the hub and spoke topology, in the sense that we have one VNet where we have our gateway device, our VNet gateway configured within that VNet. And that VNet will now be the one that will have a direct connection with the on-premises environment. So how do we do this? Here is where we create the gateway subnet. So we create the gateway subnet here that will make that connection with our on-premises environment. So only the VNet that needs to have a direct connection with our on-premises environment, that's where we need to create our gateway subnet. So we do not need to create our gateway subnet in every other subnet every other VNet that we have, because there is no direct connection between them and the on-premises environment. So if we want to connect two VNets that exist in Azure together, what we need to do is just to do a VNet peering by coming to this blade here, and like I said, click on add. Then this is checked for you already. You do not need to do anything. I can just say VNet 1 peering, whatever name you want to give it. Then what VNet do I want to link? So most times what I do is I just do VNet 1 to VNet. So it depends on your naming configuration. Then this one is going to be VNet 2 to VNet 1. Then here you need to select what VNet you want to connect this to. Then I can pick this. Then this is VNet peering test. Then I can just add this, and you can see, you will notice that once this connection is done, the status is going to be connected. So if you go back to the other VNet that we've connected to, which is the traffic VNet, you do not need to create a VNet peering, in the two VNets. You only have to create it within one, and the other one will, be connected. So if I go to the VNet peering, it will show up here. You can see connected. So that's it. So you can see my gateway transit is disabled because there is no connection. I'm not doing a connection between this VNet and my on-premises environment, and that's why I have it disabled. All right. So that's it. Any connection. So we need to configure the VNet peering and also confirm on the second network that is connected, which we've done. Any question before we go ahead? All right. I guess there is no question. So I explained under the service training that what that really means is you want to determine, when traffic is coming into your virtual network, you want to determine how the traffic will be directed, what will be the next part that you want to direct your traffic to. So we call that route. So we can do a user-defined route where you will be the one to determine where to direct that traffic. In that case, you need to create what we call a routing table, because you want to manually configure where you want to direct your traffic to. Then there is something we call a system route, which is actually determined by Azure. It determines based on the service that you have actually deployed. Is going to determine where will be the next path the traffic will be directed to. And that's what you can see here as a system route. So here we're going to be looking at custom routing table, which aligns with the user-defined route. You understand? So then we look at the service endpoint and the private link. So there are some devices in Azure, they make use of the VNet. However, you cannot configure VNet on them directly. So you need to create what we call a private link if there is a need for you to assign an IP address to that particular service. A typical service like that is a database. You know, you cannot, it doesn't take an IP address directly. So it just it's not like our virtual machine that you can get an IP address on it. So there are some devices, they don't take an IP address directly. So you can only assign an IP address to them by configuring what we call a private link on them. Then we'll talk about the service endpoint. Service endpoint is where, what are some of the services that you only want, or let's say you want to allow um, a connection to. It might be, private, it might be public, depending on what you want to achieve. So let's take a look at, this. Here is just explaining the system route. Like I've said, this is being determined by Azure, it's being determined by the system. You are not the one determining the flow, in this case. So it's just like when you have a public facing application, and you've configured port 80, that would be the HTTP port where you want to, allow users from outside the organization to be able to access your application. That means you need to allow traffic from your VM. So it will be from the VNet where the VM is configured to the internet. Automatically, the system will determine that, and that comes under, the system route. So in this case, where we have maybe a direct connection between, our VM in the same subnet. So system routes knows that, we need to, from the front end, you have to go to the, maybe from VM1 to VM2, from VM2 to VM1. So you don't determine that. So that needs to be done, automatically. So if you have VM in different subnets within the same virtual network, you don't determine where the traffic goes. That's not determined by you. The same thing, like I've just explained, traffic from one VM to maybe to the internet. In case of maybe you have a connection between the VNet and the internet where you have a public facing application deployed on that virtual network, virtual machine. So, and some other ones like VNet to VNet peering, you don't determine the next route. You don't determine how the traffic will be sent. It's determined by the system, and that's what you can see here. As against when you have a user route where you will be the one, the user-defined route where you'll be the one to determine what will be the next up, where will the traffic be directed to. So you can typically get this question, during your interview. What is the difference between user-defined route and system-defined route? So you can see this route contains a set of rules called route, which determines how packets are called data, traffic, how packets should be routed within your virtual network. So you are the one determining, where should be the next, the next hub, the next device. What should be the flow of this traffic, coming into my virtual machine, coming into my virtual network. So you are the one determining, where the traffic should be directed to, and that's what we call, the user-defined route. Then this is just, some demonstration. Let's take a look at that also. So let me just go to, so instead of you searching, I can just create a route table, come here, just the same way you've created maybe your inbound and outbound rules. It's not going to show up until you create it. So I'm going to give it a name and say test route, propagate gateway route. Yes, that's fine. And I'll create this. Just hold on. Okay, this is done. And here you can start adding, what routes, what do you want to call this route, test. So here, is it from an IP address or from maybe a service, maybe application gateway, a VM, whatever, maybe. So you want to say, let's say you want to push this from a Windows virtual desktop to the internet. So you will be the one to determine, where the VNet or where the traffic goes, or you want to push it from, let's say application gateway, whatever service that you have in here that you want to, direct traffic from. You can pick any of these guys. Let me just stick with this. And, you determine where would be the next. You can put an internet, if this is a virtual network, or virtual appliance, or you want to, if there is a virtual appliance, so the virtual appliance comes with an IP address, you can determine what IP address to supply here. Then if you want to direct this to an on-premises environment, you pick what we call, a network gateway. So that's a VPN, VPN gateway. So you can create this. And how does this work? Yes, we've created a routing table. How does it now work? So we can now select what subnet we want to associate that particular route with. So we can determine, I can pick any subnet here, any virtual network here. Then I can pick one of the VNet, or sorry, one of the subnet within that virtual network. As you can see, not all my VNet shows up here. Why? Because this guy is regional based. So you have to be within the same region where your subnet or your VNet is, or else you'll not be able to deploy it. So your routing table needs to be in the same region where your VNet is. That's when you can, you can actually see this, and have to be, within the same. You can see you have to be within the same resource group also. So you cannot do cross resource group, or cross subscription or cross tenant with your routing table. And that's how, so if I click on this, I can now assign. If I assign this, that will be a problem with, the connection on some of my VM that sits in that virtual network. So I'm not going to assign it. So this is just telling you how to create a routing table. Then how do you add a route, which I've done? Then how do we now associate, your route table to a subnet? I'm sure that explains it. So the last one is the service endpoint. So like I said, this is just adding an endpoint. You're saying for this network, you do not want to open it. Yeah, Faladin, please go ahead.
Yeah, thank you. Please, I just want to ask in that previous slide,
Yeah.
how do you know what to select exactly in terms of where where you want to route the traffic to? Because I could see it's bringing up quite a lot, like a list of different things you can pick.
Yeah.
So how do you know the right one that you're supposed to select?
So
Precisely.
depending on this depend on what your company needs is. You understand? Now, if you deploy a load balancer, which is an application gateway load balancer, you get, and the application gateway load balancer, this application gateway can be public or private. If you deploy a public application gateway, if you create your own routing table, you need to forward the traffic from your virtual network to the internet. Do you understand? The good thing is you will always have a documentation that tells you where to forward your traffic, depending on the scenario, that you are working with. So you can see something here. This guy is saying, let your Nest Hub be your virtual, it should be your virtual appliance. Let your Nest Hub should be the IP address of the node hosting the pod. So when I create a virtual machine that is hosting my application, my Nest Hub should be, the IP address of that virtual machine hosting my application. This is just, a typical example of how to know where to forward your traffic to based on the routing table that you are creating. Do you understand?
Okay. Yeah.
Yeah. So you can see, depending on whatever one you are creating, where do you want to route this to? What routing table do you need to create? And so depending on the service you are leveraging on, that's how to know where to at least forward your traffic to. All right. So service endpoint, basically, like I said, this is just like you trying to restrict your, how can I put this? You're trying to restrict your virtual network service, to a more secure or direct connectivity. So when you want to direct your connectivity just to a particular service, so you can select what service do you want to do. Like a storage account now, storage accounts will not come with an IP address, and you want to direct traffic to it. So you can take advantage of what we call, a service endpoint and pick it. So then private link, I explained what the private link is used for. Let's say, just like I've said, a typical example is your SQL, what this does is, because most of these guys, they don't come with an IP address, and you want to assign an IP address to them. You want them to also be connect to the internet, so you can have what we call a private link created. And this private link, what it does is assign an IP address to this resource. So private connectivity to services on Azure. Traffic remains on Microsoft with no public internet access because it's a private link. So you can do a private link by assigning, and this is going to be within your environment. So it comes with the fact that all those resources are actually secured. So you're only saying, and when you have assigned a private link to a particular resource, that resource will not be able to, people connecting from the public environment will not be able to access that resource until you take off that private link on that particular resource. So yeah, this is what is explained. So you map, a resource to a private endpoint, and that's what we use, private link for. And this is just so, like I said, I think even if you have not created your Azure environment, you can still take advantage of some of the sandbox. So what I'm doing now is I'm creating some videos that explains each of these labs, and I'm going to be using the sandbox and also be using the Azure environment, whichever suits you, whichever one you want to go with, you get. So I think before the end of the week, I should be able to post all those videos. Then this is the lab that explains, our intersite connectivity. Just some of the things we've done here. You need to create virtual machine within your virtual network. Then you need to create a virtual machine in another VNet. Then there's something we call the network watcher. This network watcher, as the name implies, only monitors what's going on within your network. So you do not need to bother yourself about this. But this is one of the reasons I said you guys need to always go to that Microsoft Learn documentation, because you get to read more about some of the services I might not talk about in class based on what I have in these PowerPoint slides. But those things are actually within that Microsoft Learn environment. So if you read anything and you're not clear, or maybe we've not discussed it in class, please, you can bring it up here. And that's why I always say, if you don't really have the time, because I know everyone here is just everyone here is extremely busy. So what you guys can do is just go to the labs. That lab should not take you more than 30 minutes, and when you go to the lab, you have questions, you'll be able to go in deep. You can even search Google for some of the terms mentioned within the lab that maybe you've not heard of in the class, and you just want to ask that question. I'm always here. Even if I don't know the answer, we'll look into Google together. But at least so that's what the network watcher does. Then they are asking you to do or create a virtual network peering between these two networks. Then you are going to test if the connection is done properly by using a PowerShell to test that connection. So you are going to ping from one virtual network and ping the address of another virtual network. And then you need to create a custom route, which majorly we've actually done like 50% of what is being asked in this lab, during the course of the demonstration. So I want you guys to look at that. And this is just the architecture. Create one lab, create one virtual machine within one virtual network, and create another virtual machine within another virtual network. Create what we call a VNet peering to connect this guy and this guy. There is actually a network watcher that watches, what's going on within the two VNets, and the PowerShell to test if there is a connection between this VNet and this VNet. And that brings us to the end of this class. Any question? This is why I love my class. You guys understand it like almost like every time. You don't ask
I
questions.
wanted to ask a question. Sorry.
All right, please go ahead.
Um, when you explain something about creating a network, sub-network, we can create a network like an IP. We can determine the IP that we wanted to use. What of we created an IP that has already been exist? Isn't there going to be any clash, or is there any IP that we created? Is it going to be for our own workstation, or it's going to be general one that nobody can create the same IP that we created for our network and for our subnetwork.
Okay, so let me answer that question before I take Marvin's question. So this is your own organization. We don't care about what is happening in other organizations because we do not have feasibility. Yes, the IP address that you have used in your environment will surely be used in another person's environment. We do not have any problem since we do not know, anyone in that environment. There is no merge going on. It's not as if we bought the other company. We can start at least in our own environment. We need to plan our IP addressing very well. Now, let's take, for instance, Access Bank and Diamond Bank. There is now need for us to pair those or merge those two organizations together after, Access Bank purchased Diamond. Now, we now notice that inside the Diamond environment, we have conflicting IP address space. Like what we have in our Access tenant is what we have in our Diamond tenant. Then, if there's a need for us to pair those two networks together, we will not be able to. So that means we need to start planning, how to reconfigure those virtual network again. But as at the time when there was no merger, we only have to plan based on what we have in our environment. So if you are using 10.1.0.0 as your own VNet address, IP address space, it's possible I'm using the same thing because that's a different organization. You understand? But within your organization, just make sure you plan it well. Does that answer your question? Are you there? Mr. Bakari, are you there?
Yeah, I'm with you. Yeah.
Does that
Thank
answer your
you.
question?
I'm with man. Yes. Thank
Thank
you.
you.
I appreciate. Thank you.
Marvin, please, you can go ahead. I can't hear you. Can anyone hear you?
No.
Oh, I think he left.
No.
Okay, I think his network, his network gave him out.
It could be network.
Yeah, it should be. All right, any other question? I love you guys. When I start asking you questions, I'm sure you.
Sorry, let me ask
Let's
you.
go and read it and come back with questions.
Sorry,
Okay.
are we going to write exams on all this topic you have been teaching us for the past 4 weeks now?
So the truth is, do you want to write exam? If you want
my lecturer once said that examination is a true test of knowledge. So probably we should test ourselves from that angle.
It's a true test of knowledge.
But
in this case,
only you will write the exam.
What you are doing is your true test. Can
you hear me now?
Yes, I can hear you now perfectly.
Yeah, my question is, after creating the 3D subnet IP address,
yes,
how were you able to identify the VNet 1 and VNet 2 that makes you that you're able to pair them together?
Okay. So this is a different VNet entirely. This is the VNet I created. It's a different VNet. Now, if you check this VNet, I'm not concerned about the subnet. What I'm concerned about is the address space on the VNet itself, because we are not doing subnet to subnet peering. What we are doing is VNet to VNet peering. Now, based on the planning, I noticed that this VNet is actually on 10.1.0.0, which is, a network address on its own. Now, that means any resource that will be deployed within this VNet will be within this, we take this IP address space, which is, it will be between 10.1.0.0 to 10.1.255.255. So when we start assigning, let's say I created a virtual network, a virtual machine with this VNet now. My virtual network IP address can be 10.1.0.5, 10.1.0.17. Do you understand? Now, that's done. If you check my other VNets, let me go back to the other VNets. I'm going to duplicate this tab. So if I duplicate this tab and let me go to, this is the other VNet I've created. And if you check the address space, this is 10.5.0.0. So I've planned my VNet address space very well. Now, why do I need to now pair these guys together? So, because let's pretend that there are resources, there are virtual machines there, or there are resources there that needs to talk to resources deployed here. So let's pretend that this is the VNet where, resources deployed for our Nigerian office. This is where all those resources, are. Then we have resources deployed for our UK, offices here. Then we are saying we need those machines to be able to connect together because we want to share some files and folders. You understand? Because we want to share some data. So that's why we'll go ahead to create what we call a VNet pairing. We don't just create a VNet pairing out of the fact that, yes, we want to make use of VNet pairing. No, there will be a need for us to create it. And the need is we want to allow those devices in those two different VNet to be able to communicate with each other. And we can only do this VNet pairing when we do not have an address space overlap. Address space overlap in the sense that, let's say we have 10.1.0.0 and we still have 10.1.0.0 here. It's not going to work, So we need to make sure that we have two different, those two different VNet needs to be on different address space. Let's now take, for instance, we have another VNet. So I'm going to duplicate this again, which is going to be the third VNet. And that should, we should have, let me pick one of these guys. I know this 10 monitoring should be on 10.0. Yeah, which is fine. Now, you can see here that I have 10.0.0.0, then 10.5.0.0. So I can do VNet pairing for all these guys. So if I want to connect this guy, which is the VNet pairing test, this VNet and this VNet together, I can do that by creating a VNet pairing on either this guy or this guy. There will be that connection. So the fact that there is now a connection between this guy and this guy, this guy and this guy, doesn't mean that resources in here will be able to connect to the resources here. If I want that to happen, I need to still have a VNet pairing between this VNet here and this VNet here. That's when all these VNets are now connected together. Does that answer your question?
Sorry, can you come again? Sorry. I didn't get that, please.
But you are not the owner of the question.
I know.
Yeah, can you come again, please? Please. Okay. And at the end, you said you need to test it if it is working.
Yes, you need to test it. So how do you test it? You need to deploy a resource in each of. You need to deploy a resource in each of these guys. Do you understand? So before we even do that, let's say so let me go and look for, so let me explain this before I start to talk about the connection between this guy and this guy. So what I said was we have 3 VNets here. This is the first VNet, this is the second VNet, and this is the third VNet. We want resources in here to be able to communicate with the resources in here and resources in here. We want resources in this place to be able to communicate with resources in this VNet and in this VNet. Same way, we want resources here to be able to communicate with this one and this one. Now, if that is the case, we need to create a VNet peering between this VNet here, which is the VNet 1 and VNet 2. This will allow resources in this VNet to be able to communicate with the resources in this VNet. We need to create another VNet peering between this VNet here and this other VNet to allow resources in this VNet to be able to talk to this VNet. Because I've created a VNet peering between this VNet and this VNet, this VNet and this VNet, doesn't mean that this VNet and this VNet are paired together. That means resources in this VNet and resources in this VNet won't still be able to communicate. Even when this guy can talk to this guy can talk to this guy. Because I've not created a VNet peering between these guys. So if I want that connection to happen, I need to still create a VNet peering between this guy and this guy. That means each of these networks, I will have 2 VNet peering, created on each of these VNets. Does that answer that question?
Yeah, thank you.
Yes.
All right, thank you. Now, how do we now test it? So let me go and look for connected devices on my VNets. So good. I have a virtual machine deployed within these particular VNets. Let's see this guy. Do we have? I know there is nothing here because I just deployed this one. So I'm going to move this guy. Hey man. Connected devices. Good. So let's go here and start this guy. So I'm going to, what's the lab 69? Then where are my machines? This is running. It's a Linux machine. Oh, good.
I really wish you don't have these ones already on your VM. It should be easy for us to see how you really created it from scratch.
So create a virtual network, a virtual machine.
No, I mean all these ones you're having these VNets.
That's what I'm saying. To create your virtual machine, just do this. Create, which I said is going to come, then select, I'm going to create it here. Then I can say test machine. It doesn't have to, so select the region, availability, I'm so sorry. So yeah, let's create I'm going to select the operating system, which is the image here. I'm just going to leave this guy as default. This is the size of my machine, depending on the kind of machine you want to deploy. Let's pick this guy. This one might be okay. It's just for testing though. I want to allow. I go to networking, and I'm going to pick one of the VNets. Oh, let me see. Where did I deploy this VNet? VNet Peering is deployed where? Region, UK South. Okay. West South. Okay. Zone 1. Machine. Networking. Net Peering. And data machine. Yeah. Initializing, summoning, and the next one will be deploying. So it's not more than that. This is how to create your virtual machine from the Azure environment. So I'm just going to wait for the deployment. I think it takes like 3 minutes or so. That's almost done. So you can see there are a lot of resources being deployed. It's creating those resources one after the other. You can see we've created. So that's why I didn't create this guy. We've created the network itself. We've created. So he created the public IP. Then here he just created the NSG. Then now it's creating the virtual machine itself. So let's wait. So you can see the template, why that is working. You can see this is the way the ARM template looks like. This is what you can see depending on whatever you are creating. So if I'm to deploy a VNet, a virtual machine of the same size the next time, I can come here and download this template. So I don't need to start writing template from scratch. I can just download, and so this resource is deployed already. And if I want to, so this is still not ready. So I'll wait for this guy, and you will notice that here it will have deployed, has given me a public IP address. I can copy this. Let's see if I can. I know it's still loading, but let's see. It might be done. It might just be waiting. So I'm going to, access this guy. Let's see if he's. So you can see that is the same machine I just deployed now. And that's the same machine I'm going to access now. This is just like the first time you got a laptop, and that's what you'll be seeing now. It's going to start configuring, from scratch. This is, you can see this is just setting up a new window for me. While that is setting up, I'm going to start the other one so that I can do the testing. So you can see my IP address is up. Sorry, my VM is up. You can see it's been deployed. It's asking me to join. Do you want to allow us to hold on? I'm going to start the other one. So let me just go and quickly start the other guy. So this is started already. This is, so I need this other guy. I'm going to start it here. So the machine, I'm going to copy, because what I need is the IP address. I don't need, because I've done what we call a VNet peering. I don't need a public address. So, okay. So I'm going to do a test. This should work. I don't know why, because if I do a ping on a normal day, I should even still be able to ping the public IP address without even doing any VNet connection. Just hold on. Yeah, VNet connection. Then that will be this. Then ports 3389. Yeah. So attempting TCP connection. Let's hold on. Yeah, this is connected. I don't know why it's not pinging from the command prompt, but this is connected. You can see TCP test succeeded too. The source IP address, this is 10.5, and this is the destination IP address, which is the 10.0.0.8. So I don't know why it wasn't pinging, but this shows you that, there is a VNet connection between, because I'm pinging, I'm able to at least talk to a private IP address, which is on that virtual network. So if I'm using a public IP address, that means even on my own physical system, I should be able to at least ping that IP address, which is fine. But within here, if you want to make sure that at least that particular VNet peering that we've done is working, then we'll be able to do this. So let's go back here and delete that VNet peering, then check if we are still able to at least ping that particular IP address. So I'm going to take it off and just hold on. So I'll take this off, which means there's no connection between them anymore. Let's hold on. So this is gone. And I go back there. And I try to, do the same thing again. Definitely this should fail. So you can see now that's failed, meaning that connection has been taken off. So yeah, TCP test succeeded. Now it's false. There's no connection between those VNets anymore because we've taken off the VNet peering. All right. Does that make sense? Are you guys still there?
Yes, please.
Yeah, so
All right.
yeah.
Yes, we are,
Okay,
yeah.
sorry, if I may ask, all these VNet, this pairing of a thing, most of the time is usually temporary, just for a particular time, probably to make sure resources communicate for a particular time, then it's yanked off. It's not as if it will be stable and it keeps going while the systems are running. No.
Why do you want to yank it off? If there's a need for you to do that connection, there's no need to yank it off.
Okay.
Yeah. It's just telling you, you want to pair two networks together. You want Office A to be able to see Office B.
Yeah.
Except if you guys do not want to merge anymore, if there's a need for you guys to have separate environment, then you want to yank it off. But there is no reason for it. It's not temporary. It depends on the organization need. If it's what you want, you really want your resources to be able to talk to each other, well, then there is no reason for you to yank it off.
Okay.
So I'm sure I've completed, actually I created the virtual machine also. So you guys should not have any issues, replicating that in your environment and also completing, this. So any other question before we call it a day? All right. I think I call it a day.
All right, thank you.